Welcome to the Android Summit 2019. We're incredibly excited to have everybody here. So thank you for joining us. In case you didn't know, this is our 5th year. So we're really excited about that milestone. I always like to see how many new folks do we have that have not attended our event before. Can you raise your hands? Wow, that's fantastic. Also, thank you for all the returning folks. It's great to have you here again as well. And I have a clicker in my pocket. It's not going to happen unless I actually push a button. So welcome everybody. We're really excited for this year's event. We have a beautiful event space here, so love to just give a great shout out and thank you to Capital One for sponsoring the event this year. Every year we have had a different space, and there's always interesting things to work through, but everything's been going beautifully so far. We've had other events here, so we're just really appreciative to be here. Boop. Okay, super important thing, and I'm always gonna go back to our first year and our first keynote speaker. Chuki Chan, when we had reached out to her, and she was like, yeah, I'd love to do your keynote. And I was like, that's awesome. She said, well, what's your code of conduct? And never having organized an event before, it's like, I don't know. She's like, you need one. It needs to be on your website. So we went and stole the one right off of DroidCon, New York. So somewhere, Kevin, there you go, Kevin. Thank you for that. And we put that up on the website, and we just kind of poured through, made sure that we were being really thoughtful and responsible, and appreciate Chuki for pointing that out to us. So ultimately, this is all about creating an environment where folks can just really be themselves, really enjoy themselves, and relax. So we want to make sure we're providing an environment that gives you the greatest opportunity to do that, and just come and enjoy the event, the speakers, the learning, the networking, socialization. If for some reason, and I do not anticipate, we've thankfully never had anything happen where folks, at least that we understood, were uncomfortable with it, but if there's anything going on where the experience isn't optimal for you, please, please, please grab one of the folks in the green shirt, and we will do everything we can to take care of things for you right away. Do not hesitate. We are here in every way to support you, and I'll talk a little bit more about that in just a minute. Okay, logistics. Toria is super important here because I'm probably going to forget half the things she told me to say. A couple of things, just from a security perspective. There's a set of beautiful stairs off to my right here, so if you come out, it's to your left. We need to make sure that all of the attendees don't go beyond those stairs ultimately. So just stay in this area. We've got right behind me are the breakout sessions for all the talks. In the back left here are 2 of the rooms for the workshops, and we'll be utilizing this space for our keynote as well as, I believe, the end of day fun and lunch. Oh, and lunch, fantastic. Another logistic, the whole grounds here is a non-smoking facility and grounds, so awesome. So please be mindful and respectful of that. If for some reason, you really need to, just grab a green shirt again, and we can help you find somewhere where you can do that. Yeah, so we'll help you there. Wait, actually, did I miss anything that you needed me to? No. If it comes. Oh, with Maplewood. Okay, so the reception at the end of the day today is a fantastic opportunity because you come here to learn, but I hope you all understand and realize this is such an amazing opportunity to network and just get to know people. There's so many different companies represented here, both in our speaker population and our attendee population, and that is an amazing, amazing thing to take advantage of and just generate some great conversation, learn about how other folks are solving similar problems that you may have. And just enjoying each other's company. So do come for that. We do have, actually this will lead me right into, no, not into that. Okay, I should know the order of my own slides. Yeah, you'll end up taking the stairs up to a room called the Maplewood room. So it's a beautiful room with a little deck overlooking all the construction. So it's awesome. Okay, this super important. The app for the conference was developed by our team, and actually it went live last year for last year's event. It's been updated this year. It actually supports Android and iOS this year. They had a very clever way of working through the App Store rejection process. Basically, don't call your app Android something if you want it to get into the iOS store. So it's called Events Plus, but what's great is it's completely built in Flutter. It was built last year by Johnny Pepin and his team of interns, and they've continued to advance that. It's all cloud enabled and all that wonderful stuff, but it supports multiple events. So you'll need to plug in this code as the event code, AS 2019, and then you'll have access to all of the sessions, speakers, you can bookmark. From within the app, you can actually tweet from there as well, and it'll already pre-fill the hashtag for you, which is very convenient. Okay, I started to allude to this before. The reception later, we are gonna have some prizes. We'll do some drawings for that. And it's definitely a must be present to win. So just one more little thing just to hopefully incentivize folks to come out and enjoy and socialize, and maybe you walk away a little extra something. Okay. Tweet or it didn't happen, I think is the saying, right? We would love to just hear about your experience and the folks that you meet, the pictures that you take, on social media. So if you don't mind to use this hashtag in all your posts, if you do it through the app, you won't even have to type that much in. It's really helpful for us just to get a sense of how are we doing as a conference and how are we supporting all of you, and are we creating an environment that is allowing you to just enjoy yourself, because most times when you're enjoying yourself and you're having fun, you tweet about it. Boop. I mentioned before, if you see a green shirt, now there might be some people here, the first year we had green shirts, there was somebody that came with a green shirt, and I had to always say, like, go to anybody with a green shirt except that person. But I don't really see any of these green shirts. Anyway, we'd say event staff, says it on the back, but grab us for anything you need. We are here to make sure your experience is as awesome as possible. Even if it seems like a crazy request, grab a green shirt. We want to help you. We gathered as a team yesterday, and we're all super excited about, all right, we're ready. We're so ready for all of you. And our job here today is a simple one. It doesn't get any simpler than that. Make it awesome for all of you. So please let us know how we can do that. And even if there's things that you see that you think, hey, could be a little better, we'd love that feedback as well. So come grab a green shirt if you need anything. I'd be remiss without just at least mentioning our sponsor and partners. So the event is entirely sponsored by Capital One. It's a very large expense. In terms of the event space and security and food and all that stuff. But Capital One's very, very big on integrating into the community, especially the engineering community. And that's a very important aspect of what we do. It's a real way of demonstrating your intent to be a great tech company, not just a bank. We are partnered with MoDev and GDGDC. And I'm looking behind me, and I forget that there's things right here that make it easier. Sorry about that. And DC Android. And as always, every single penny that comes into the Android Summit, all 5 years, goes directly to Women Who Code. None of that money flows through Capital One whatsoever. We raised over $7,000 this year for Women Who Code, so I'd love to thank all of you for that. You made that happen. And I have a couple other thank yous I just wanted to run through real quick. One, if I could just have the event team, the folks that are in here, just stand up, all our green shirt friends. And if it would, come on, stand. This is an amazing group of people. This event planning starts in January, goes through the entire year, and all of these folks have worked so tirelessly to bring this experience to you. We think through all the logistics, think through like how are we growing as a conference, what are the things we need to do better, what did we learn from last year, and how do we want to approach our structure of the day. All those little details get handled by this group, and I just couldn't be more grateful for this team and all of the hard work they've put in through the entire year. I want to go quick, so I'm not going to go through and single out everybody, but I would love just a huge round of applause for the team. The other thing I'd like to do is thank all of our speakers. we provide a structure for the conference, but you're the reason people come. And we're really grateful for not just all the time you put into your talent and your expertise, but to actually take that extra effort to share what you've learned with other people. It's a great gift to all of us that you would take the time to do that, and we're all better for it. So I would love to give a huge round of applause to all of our speakers and the hard work they put in. And lastly, you're going to clap one more time. I hope you're going to clap. I'd like to thank all of you, because we can have an event team, we can have speakers, but if you all don't, stop and say, wow, this looks interesting, this is something I'd like to do, and take the time away from either job or from family or whatever. Some of you maybe even traveled, a ways to come here. We're really grateful for you. This is all about providing something that we can all engage in as a community together, and you are that community, and the conference is nothing without a community. So again, a huge thank you to all of you for being here today. We're really grateful to have you here. With that being said, I'm going to introduce Jared Sheehan, one of our core event team members, who's going to introduce the keynote. Thank you.
Yes. Thank you, Michael. So first of all, I want to also say thank you from all of us here on the event team for coming. We really, really appreciate it. We've got, we're actually, it looks like we're completely full. So awesome. Thank you all for coming. Michael shared the slides with me yesterday and said, hey, add a few slides to introduce Chet Haase as our keynote speaker. And I added about 30. So I promised myself I would go home and I would reduce it some, and so I did, and I added 2. So I will try to go through this fairly quickly, and I apologize up front. So Chet actually, I've known of Chet for a very long time. He's been on the Android team since 2010, I believe, working mostly on the UI toolkit part of the platform. And there's a lot of value that I think Chet has brought over the years to the Android platform. So first of all, how many engineers in here have been working on the Android platform for 2 years? How about 4? 6? 8? 10? I'm literally almost to 10, okay? So there have been lots of things that his team has added that have really helped me. There are lots of how-to videos, lots of screen captures, and lots of things that he and his team have put together to help really me and a lot of engineers in this room grow in their career. So I'm going to talk a little bit about some of the things that I learned and whether they're still there. All right. So did anybody use the memory allocation tool built into this thing called Eclipse? Yeah, it was fun. That's what it looks like. And this is what it looks like now. Okay. So fortunately, we don't have to worry about that anymore. The next one, hierarchy viewer. Yep. That thing was amazing. It looks like this. It looks like a Nintendo 16-bit game system was put together. This is how you figure out where your extra 10 pixels of padding are living. Okay. This is how you used to do it. That's also been deprecated. Another one, which actually encompassed a lot of these tools, was called the Android Device Monitor. And there's about 6 things here. You'll see hierarchy viewer there as well. There's trace view, systrace, a way to really do some debugging. I didn't add 9-patch. Who's heard of 9-patch? Yep, it was great. It is also not there anymore. Now there are a lot of better options. I can't tell you the number of videos I would watch with Chet and his sidekick, Roman, or are you Roman's sidekick? Who would talk about really cool things and then say, but it's really hard in this thing, we're gonna fix it. And they have. They fixed a lot of this. So we have like layout editors instead of hierarchy viewer, instead of async tasks, we have coroutines and flow. And so I think one of the things that I really loved about Chet was he was a heck of an engineer. He would do lots of videos, really explain things I thought really, really well. He's a blog poster, and you'll see later he's a heck of a comedian. But I'd argue that his greatest value is actually to him being a teacher and educating an entire generation of Android developers. So first off, I want to say thank you. Next, that's awesome. So how do I get them to come to my conference? Because I'll tell you, it's not easy. All right, so I'm gonna talk a little bit about how I did that, and I'll try to go decently fast. What you do is you'll see the date on there, that's 2016. You tweet at them and say, please, please come to my conference. And I'm sure that happens probably 10 times a day. Sometimes you get really lucky, and he responds, okay? So he did right here and said, hey, thanks. He sent me a DM. He's like, really appreciate it. I'm pretty busy. And you've got a pretty solid set of speakers. And you'll see right up at the top, he explained in very nice terms that he's got an actual job to do. And some of the speaking stuff he does on the side is not really part of his job. And so it's kind of hard for him to get away, which is totally understanding. Cool. So then I tried to get in 2017. And he said the same thing. He's like, sorry, it's not my job. Got lots of things going on. Appreciate it. I'm going to fix that platform for you, you know. And I tried to get in 2018, you know. But he was, again, very, very nice about it. And then I saw something really interesting on Twitter. Look at this. He changed jobs. So now he's part of the DevRel team at Google. So I sent him a message and said, hey, how about now? And that was my response. I'm like, yes. And he finally agreed. Moral of the story is if you don't succeed, keep trying and trying until they give in or they get a new job. And oh, by the way, he actually agreed to come in his Top Gun gear, so I'm really excited to see how he gets from there to here in his Top Gun gear. So without further ado, I would like to introduce Mr. Chet Haase of the developer relations team at Google on stage and also from Top Gun. Thank you very much. Thanks. You're welcome.
Oh, I should totally turn it on. Here we go. Yeah, I forgot my jacket. I'm sorry about that. I'll try to do that later. That's me. That's nice. We should probably switch to the slides and actually start the keynote. What do you think? Wow, so great to be here. And hello? That's not even on my slide deck. How did it get there? All right, good.
There we go. Awesome.
Yes, so let's talk about Android development. So usually when I do a keynote, it's because I submitted a tech talk to a conference and they say, oh, you want to do a talk? Then you can be the keynote. Like, well, it's not really a keynote. We're going to tell you how the garbage collector works. It's a keynote. Okay, it's a keynote because there aren't any other talks happening, and so we do a tech talk instead. I thought for this one, since Jared was specifically asking me to come out and do a keynote, maybe I should actually try to figure out what a keynote is. I haven't actually written one before. I just write tech talks, but I thought, well, we'll try that. So I want to talk today about a little bit of history, and is this going to work? There we go. A little bit of history and a little bit of current, sort of where Android came from, how the platform was developed, some sort of key things that I think about in the releases that we did over the years, and some key things that we have done in the past couple of releases, the past couple of years, and the focus of the team, the platform, the engineering team right now, to sort of give you the context for where Android is at right now and how you should maybe think of where it's going in the future and how that affects the development you need to do with Android. But first, before I do that, I did want to say thank you to some of the people involved with the event. First of all, Wibenu Code for helping figure out the financial part of this. I think it's pretty fantastic that they have this amazing conference, hopefully good things to hear about from the other speakers here. And yet they take all the money that could be benefiting somebody with some sort of profit motive and give it to an organization that's trying to do good things for developers instead. That's really awesome. The other person or team that I want to thank is GDG DC. In particular, I want to call out Tyson Kemp, who I had the privilege of meeting this year at Google I/O. Tyson has been an organizer on the GDG DC team for, what'd you say, 10 years? Long time helping out the community. And last year, he had kind of a horrible accident and has been recovering from that ever since. And yet, he still made it out to Google I/O this year because he's so passionate about development and about the community that he wanted to be a part of that. I wanted to point out as well that the team, the GDG DC team, set up a GoFundMe for Tyson. So if you feel like appreciating the team and what they do, and Tyson in particular, this would be a good way to show it. Finally, I want to say thank you to everyone here for bringing me out here. This is actually a homecoming for me. I grew up partially in the DC area. I went to middle school and high school out here, and then opted to not come back. And when I think of coming back to Washington, DC in the middle of August, this is kind of what I picture. It is, in fact, emotionally, but also just physically a swamp. I thought, this is actually the worst time of year, as I remember DC. It's not the 85%, it's the 200% humidity. And then I come out to the Tyson's Corner area. Now, I grew up in this area a long, long time ago. And when I think of Tyson's Corner, I think there was a mall, there was a couple of Beltway bandits across the street. But this is sort of a picture of my mind. That was Tyson's Corner at the time. And now I look, I didn't even recognize it. I didn't recognize the mall that I drove past. I'm staying in a hotel that I believe is 2 blocks from where I used to work during the summers, and I don't recognize a thing over there. This is Tyson's Corner now. If you recognize this, I certainly didn't. The other part that I think of with DC is the traffic that is everywhere. This is why I opted to not come back. I thought, you know what, DC's nice. It's really beautiful here. It's lovely. It's super crowded and very expensive, so I don't want to be a part of that. And now I'm in the Bay Area. Something went horribly wrong in my life. Now let's get on to some of the technical stuff. All right, so then and now. I want to talk about where Android came from in the beginning. These are sort of the key pieces that I think of it as the team sort of assembled and built the thing that we now call Android. So starting in 2005, the team was acquired by Google and sort of started running. The first step that they needed to do was actually write a demo. So in order to get acquired or to seek funding before that, they basically wrote a JavaScript demo. That was Android at the beginning. Then after the acquisition, they thought, oh, it's got to be more than a demo, I bet. So reboot and actually build the platform. And once you have the platform, you need APIs because, of course, you're going to need people to write applications for these things, both internally as well as external developers. That was always part of the plan. They needed to kind of make it all work. Probably should ship a product that's going to do something. More importantly, it needed to work on these incredibly limited devices, right? They're going to ship on the G1 and then the several devices that follow that. Not a lot going on in terms of memory or processing power or any of that. So that was kind of a rush to get all of that going by 2008. And then actually ship it, again, kind of a rush to get it going by 2008. All right, so the first step there, building the platform. There were a lot of major pieces that went into that. I have these sort of layer cakes. I'm an engineer for some reason, I think in terms of layer cakes. So you can think of the platform as looking kind of roughly like this. At the lowest layer, you've got the Linux kernel. They didn't actually need to write the kernel because it already existed. They sort of took Linux and then just kind of added some things like wake locks that it didn't have that they needed on the platform. Most of what they did was to write drivers, right? So they need drivers for Bluetooth, for media, for the camera, for basically everything that they want to do with the operating system and the hardware. Then on top of that, they're going to add support for handling a couple languages. Obviously, the language that we supported at the time was the Java programming language, but there's also a lot of native code happening in there. I say C++, when you're talking about some of the things like Dalvik, there's a lot of assembly code in there as well. So a lot of the platform is sort of written at this native layer, and then there's a lot of parts that are also in the Java programming language, and then that's obviously what application developers are writing to. So you've got Dalvik, garbage collector, runtime handling, that stuff. You've got all the framework stuff, sort of operating system level with the Java APIs. You've got my favorite, the UI toolkit layer. You've got media stuff for graphics as well as audio and video. You have camera happening there. You have the lower level graphics system, and on and on and on. And then on top of that, of course, you need to add some APIs so that people can actually program to this thing. So here are ways that I think about APIs, especially back in the early days. And the decisions that the team made in the early days still affect us today. And it's because of the way APIs work, right? So if they made some trade-offs and introduced an API that they didn't really like, but we'll get it out the door and then we'll fix it next year, well, you can't remove that old API. It needs to stick around because the applications that were built last year need to actually continue working the following year, and then on and on and on. You can deprecate them over time, but you can't really get rid of them. So some of the design and architecture decisions that they made, we're still dealing with today, and we can fix it by adding things, adding new libraries or whatever, but you still see some of these historical things in the platform. All right, so they needed to maximize the functionality, but And so they added all kinds of things, these intents, they've got broadcast, they've got all these powerful capabilities, but they needed to minimize everything else, right? They're gonna run on a G1, so you've got decisions made at the API level like primitive types are awesome and objects suck, right? Which ends up affecting a lot of the APIs because we pass around a lot of integers in the Android platform, especially in the older APIs. So we have lots of methods like this where if you want to set some rectangular information, I don't know, I guess rectangles are really expensive. So we're going to pass in all 4 corners directly instead. Because this way we avoid creating the rect object, which back in 2007 was probably really important. 2019, probably not so much. We also believe in the platform team that bit fields are really awesome. So instead of querying for information that we store in an integer, which is going to take all of 32 bits, instead you should store it in 1 bit and then share that bit with 31 other bits from other fields instead. So if you want to check whether a view is selected, we actually return information that's stored in a private flags state, which you can see here. Now they started out with private flags that allowed us 32 values, and then when they needed to, they added private flags too. When I was doing platform coding back in 2010 and 11, I think I was involved in adding private flags 3, and then when I checked this last week, we're up to 4. Finally, I think like all good Java programming language developers, we feel that mutability is obviously what you want, right? I think everyone believes heavily in mutability. So here's an example of that. If you want to get information about a rect, again, creating objects just to pass information around, not what they wanted to do at that time. So instead, we allow you to create the object, pass it into us, and then we populate it. A lot of mutability in the APIs because of those early decisions that the team had to make just to ship a product that would actually be performant on these devices. All right, so we've got the APIs, and then we start developing applications. There's a bunch of internal applications that came online around this time. Markets, we'll get back to that in a minute. And then everybody's developing your apps as well. I guess it was, Jared and 1 or 2 others in the room that were maybe tuning into Android at that time. So here's what the timeline sort of looks like. So Android was acquired by Google in July of 2005. And they began platform development. Let's set aside the JavaScript demo and actually begin this thing for real. And then Google app development started internally pretty quickly after that. If you have enough pieces, you can actually start building apps on top of it, like the Contacts app and Gmail, some of the sort of Google services-based stuff. Eventually, the SDK came online November of 2007. And then at that point, people could actually start writing their own applications externally. And then we had a developer challenge. Anybody participate in that? Ooh, nice. OK, we have 1. Did you win?
No, I didn't close.
OK. All right. Well, we'll cut this out in the video. And we'll pretend that you won that. And we have a winner in the audience. All right. 1.0 shipped in late 2008. And G1 was the first device, of course. And then Market was released. And it turns out that Google is really good at giving stuff away, not very good at paying for it. So we couldn't figure out how to charge for apps on Market until the next dot release. So then we could actually allow you to make money on your apps, which turns out was actually kind of important for developers. All right, then we enter a phase which I consider catching up. So first of all, get to market. It was kind of amazing what the team was able to do in those days, way before I got there, just to actually get to the market with something that could that people could envision using. Now, it didn't capture the attention of the entire world, but it was good enough for people to sort of see some sort of promise there. And we're willing to suspend disbelief as the team continued working. But then they spent several years and several releases catching up, providing core capabilities that people really needed and that the platform really needed to be competitive in this market as other smartphone platforms were coming online as well. So here are some of the important things that I think of in this catching up phase over the years and the releases. These are all the releases. My favorite part about this slide is not shown when the laser pointer doesn't work. Look at all of the releases that they were doing in the early years, right? These were like every 2 to 3 months, stacked up on top of each other. The team was running like mad in those days. And then you can see, finally, we sort of figured out how to ship software on a regular cadence. It turns out not even our partners like this, right? If we're shoveling releases this fast on people, they really can't consume them that quickly. So annual cadence, kind of much better for everybody. All right, one big improvement was NDK. I think the team felt pretty strongly at the beginning, no, we want them using this Java programming language API. But it turns out games, and especially applications that really want to work at a very low level on multiple platforms, kind of need something like the native NDK. Then we've got densities. This is really important. So Android came built in 1.0 with the ability to support lots of different form factors, which was really key as a success factor of Android in general, because we need to make it possible for all the manufacturers to do all these crazy different things that we didn't think of, and then the applications will just work. Well, part of what made that work was bringing the idea of densities out there. So as screens got larger, more pixels, different form factors, that was actually going to be more workable for application developers in general. Turn-by-turn navigation turns out to be kind of huge at the time. That came out with the Droid release on the Eclair, the Droid device on the Eclair release. Flash. So Flash was, I don't know if anybody remembers at this time, this was the real web. I forget what the phrase they used. I worked at Adobe at the time, actually. And they used, this is the real web that people actually want to use. And it was sort of key to a lot of websites and applications out there. And Android was known at the time for providing Flash support. It was pretty important. And then there's the Honeycomb release. We did tablets. We did my favorite thing, which was animation, which is basically why I joined the team, to actually write some of the animation stuff that we have there. And then we have Holo on phones. I'll get back to that a little bit later, but very important in terms of like establishing a core design framework that made a little bit more sense, and developers could sort of develop more consistent things on top of. And then there was another Flash development that happened sometime in early 2012. We decided actually it's not the way people use the web anymore, and Flash went away. Butter, so Project Butter in the Jelly Bean release is a huge catch-up thing for us, where things had gotten big and complicated enough that we were really having what we called jank a lot, that we needed to fix. Discontinuous experiences, or just performance that was not good enough. So we focused at a really low level on how to fix that. I'll talk about that a little bit more. RTL, turns out there are other languages on the planet that sometimes use different directions, and it's kind of important for a large platform that ships everywhere on the planet to actually take advantage of that and handle it correctly. Project Svelte was about handling devices with small memory, so everything had gotten bigger and bigger and bigger over time, but there were still devices shipping in the world with much smaller RAM on them, and we needed to make sure that Android actually worked well in there. So Project Svelte was about sort of downsizing and getting things into a more manageable state for everybody. Recycler view is important because this is the first indication of where we are now at with Jetpack. So we'd had support library for years. I think Fragments was the first element of that back in the Honeycomb release. But Recycler view was the first introduction of, here's this amazing new functionality we think everybody should use, and it's not in the platform. It's in a static library that you can build into your application and use on every release instead. We've got Material. Okay, so this is another advancement beyond Holo, really sort of complete design system that, again, gave everybody a really good direction for how to design their app. It's got a pattern, it's got a spec online, it's got lots and lots of information in a way that earlier Android releases just didn't have. Then we've got runtime permissions, kind of huge. I'm going to get back to that a little bit later. Multi-window capability more recently. So we've always handled all kinds of form factors, really pretty much for phones and then tablets. But what happens when Arc++ comes along and you have the ability to support laptops? You really you need to start thinking beyond the idea of having a single window on the screen, which all phones do, but that doesn't really scale to laptop experiences very well. And then more recently, Treble, trying to address some of the problems that we have in an ecosystem where most of the devices are shipped by manufacturers who are not us. And you need to make it as easy as possible for them to upgrade releases quickly. All right, so part of the catch-up was in sort of three areas that I think of, sort of performance and design, and then the third one that I can't think of right now, so we'll get to that. Project Butter. So lots of things that we did in Jelly Bean. Optimizations all over the board, mostly at a low level. Input latency, looking at the time it takes between when a user's finger actually taps on a thing and when the results of that tap appear on the screen, right? And reducing that time as much as possible. It went down from, I don't know, I'm going to make up numbers here, but it was along the lines of like 50 milliseconds down to 17. And it was by figuring out all the pieces in in the platform where, okay, we take this information, we pass it through this driver, we pass it up there. We've got triple buffering happening. Like all these different pieces had to come into play for us to redesign around this and really make it a much more real-time experience than it was before. Triple buffering was part of this, trying to figure out, okay, how can we make a smooth experience? You have a lot of information on the screen. You want to make sure that you're not blocked and just backed up waiting for the next buffer to be available. Choreographer was the idea that we're actually synchronizing with the hardware that's actually displaying the bits on the screen. So before, you're doing stuff in the UI thread, and it would basically happen at any time, and it might narrowly miss the screen update time, which means it's going to wait for another 16 milliseconds to get there, which doesn't sound like a lot, but it is if you're a user, right? It's very noticeable. So instead, we synchronize the UI thread operations at the beginning of a display frame using this new object called choreographer. Say, it's vsync time, now go do all your stuff. All right, post-Butter, we still work on performance, it turns out, a lot, especially the runtime team. So Art came online in the Lollipop release. This is a vast improvement over Dalvik. Dalvik was awesome, but it was built with the idea in mind of minimizing memory, right? So it made a lot of optimization trade-offs that were built around the constraint that they just didn't have the memory to store the extra objects, have the extra data structures, pre-compile the code, whatever it was going to be. They couldn't really do it on Dalvik. Art was a complete rewrite from the ground up that allowed a lot of the further optimizations that they added. So in the M release, there was optimizations around the compiler itself, also optimizations around allocations. In the N release, again, allocations. They rewrote it all in assembly. I think they're now at like 10x the performance in terms of actually allocating objects than they were in Dalvik, and then more and more optimizations at the runtime. In O, they introduced the concurrent heap compaction. This was key. So prior to Art, you didn't have the ability to defragment. So as you allocated objects on the heap, they couldn't ever really be collected. Most of the ones that went away, they would be collected, but in the meantime, you've got this fragmented heap, and you're basically running out of space for large objects. And eventually, you're going to start getting errors in your application because there's simply not enough contiguous space to store stuff anymore. So with Art, they had the ability to defragment, and in the O release, they had the ability to do this in the foreground. And this was huge in terms of memory savings across the entire device. It meant that applications that never stopped running, like the system process or system UI, could defragment on the fly when they needed to. And it was much better for everybody. Also, allocations got a lot faster using a thread local bump allocator. So basically, to allocate an object, you didn't need to do a lot of complicated logic. You just say, here's how big it is, and it would place it next on the heap. And then finally, in the current release, you'll see that there's a collection for young generation. This means that garbage collections don't really need to go the full cycle anymore. We don't need to do a full GC to get memory back. Instead, we can just look at what the new objects are. Most of those have gone away because it's really common to allocate objects and then get rid of them very quickly. And we get most of the memory needs that we require on the fly. So much faster garbage collection in general. And we're always working on other things. An example is hardware bitmap. You can now allocate a bitmap that's shared between both CPU memory and GPU memory, so we don't have the extra time to copy a texture up. And the team is just working all the time. Graphics team, UI toolkit, framework, garbage collector teams in particular. All right, another big change was design. We talked about Hollow. Basically, the first time we'd sort of had this overall system in place to say, here's what the design should look like, here are some rules. Material went much, much, much further. So consistent approach across the entire design system and across apps as well as the system UI on Android. And there's a pattern for everybody to follow. Not only that, but there's a spec with it. So go to the material spec site, and you'll see all kinds of information, nice animation curves. You're not quite sure what to do with this information. It's more for designers and concepts, and how does that translate into code? So the team came out with the material design components to make that much easier. So now you can take these ideas that have been baked in the components, and you can use the code directly. All right, so that brings us to today. That was a lot of catch up over the years. Many, many more things going on in the team, obviously, besides all that stuff. But it does bring us to today, where the two focuses on the team over the past couple of years have been focusing on what the developer needs and what the user needs. So the developer needs come from an idea that, well, we introduced all these features and capabilities into the platform, And now the functionality is basically what we, the platform people, want it to be and what users need it to be. But it turns out if you talk to developers, it's kind of hard to write these applications, right? And so we went out, we had a lot of meetings, we still have a lot of meetings with developers to get their input on what is difficult about Android and how can we address that. So big focus on developer, to sort of figure out what we can do to address that need for simplicity in development, or at least less complexity in development. So the poster child in my mind for that is the Architecture Components Project, which is part of Jetpack, where we went out to these groups of developers, said, what's really difficult? And number one on the list for everybody was lifecycle. Android lifecycles are really hard to understand. I should have some of those diagrams that we have on the site. They're really entertaining because not only are they really complicated and difficult to understand, even if you read the docs over and over and over again, but they're also kind of incomplete. But that's only about activities. Then what do I do with the fragments? And so really hard for people to understand and to handle because you had to subclass activity and then override these particular methods and sort of track the lifecycle over time. So we introduced lots of new APIs around lifecycles, live data, view model to make it easier to manage all this stuff. And then we also looked at storage. Another thing that people found difficult, there were particular solutions they would end up using, but maybe we should come out with some basic capabilities in the platform. So we developed the Room library to handle that. Job scheduling was really tricky, especially because it worked fine if you were on a particular release and you were using Job Scheduler, but other than that, you were kind of on your own, right? Well, what do I do if I'm not on at least KitKat, or I'm not on the release that had this particular feature, or I'm not on a device that has Job Scheduler or doesn't have access to, I think it's Network Dispatcher in Firebase. So kind of tricky. Everybody basically was solving the same problems over and over again. So we introduced Work Manager to basically be that single layer that developers could go through. And then finally, maybe the most important was an opinionated guided development. People had asked us over the years, what architecture should we use? I've had many of these conversations at conferences, in bars, where people say, okay, so what do you think about the MV? And I'd stop them at that acronym and say, no, I don't. I really don't. I'm not an application developer. I write the platform. You should do what you want. Yeah, I understand. But what do you think about that? Like, I think you should go have this conversation with someone else because you need to do the architecture that's right for your application. We still believe that. If you have the right architecture for you, then it is the right architecture for you. However, some people are starting new on development, or they're bringing new people on the team, and they kind of want a single source of truth that will work. And so we came out with the opinionated guided development, a particular architecture that works, we believe, for the platform as well as for some of these new APIs that we're coming out with. So if you want to point people at something, this is great. If you have a different solution that works for you, great. We're not telling you to change, but at least we do have an opinion that we believe is valid. We also introduced support for Kotlin. Turns out a lot of developers are using it already because the language is so good. It worked pretty well with Android, except we would break it occasionally in the tool because we weren't really paying attention to it because it wasn't a supported language. So now it is. 2 years ago at Google I/O, we said this is supported. We're no longer going to break it in the tool. That's great. And then this year at Google I/O, we said, now we're going Kotlin first, which means many things. It means more focus on things like KTX, developing extension APIs to make it easier to write Kotlin code by adding APIs that make sense. Coroutine support, new in the language, and we're introducing them already in some of our lifecycle APIs as well as Room. So making some of the development that was already hopefully a lot easier than it was before, even easier if you happen to be writing Kotlin code. As well as Kotlin Everywhere and a bunch of other learning resources like Udacity courses for learning Kotlin, or in particular learning how to program Android on Kotlin. So the team is really investing heavily both in terms of educating people on how to use this language that we think is really good for the platform, as well as using the language internally ourselves to create better APIs and experiences for developers. And then Jetpack, which we introduced last year as basically the evolution of the support library. So we've always had the support library, started with fragments. We added a bunch of app compat stuff. We added a bunch of random stuff in there over the years. Recycler view was awesome. And then more and more, some teams, in particular the UI Toolkit team, just started going Jetpack first. If there was not a reason for it to live specifically in the platform because it depended on new capabilities, then it should really live in the standalone library instead. And then you can build it into your application, and you can use it on whatever releases you want. So Jetpack is more and more a focus for the team, not just the toolkit team now, but all of the teams internally on the platform. So you're going to see more and more stuff come out for Jetpack, including Jetpack Compose. So one of the things we also heard was difficult was UI programming on Android. So the team took a run at that and is working hard. It's something called Jetpack Compose, which is a reactive programming model for doing UI, which is apparently popular as a general paradigm for UI programming. It is not released. It's not even close to release. It's not even alpha at this point, but they are developing it in the open, so you can check out where they're going with that. All right, so that's focus on developers. Super important, obviously, for this room. But the other thing that we've been doing over the past couple of releases, at least, is to focus on what the user needs. And I want to bring this up because what the user needs affects what the developers need to do about that. In particular, some of the things that we've changed in the platform over the releases have affected developers' lives because that means that you need to change what you are doing with Android. And the thing that I wanted to try to get at today was why. So people, when internally we call it moving someone's cheese. Like when you change an API, when you change a behavior, when you tell people that they need to do something different, we've moved your cheese, and it just seems arbitrary. Why did you move my cheese? I don't want to do this thing. Why are you making me do work? And it is for a very good reason. I want to try to paint that context today. So there are 3 areas that are really important to us that matter very deeply to users. First is battery. Because the #1 requirement for users is for their battery to last as long as possible. They want to get to the end of the day and still have a usable device without playing games with weird settings and turning things off and uninstalling apps. Like, no, it should just work. Why is my battery lasting less over time? So we want to focus hard on solving battery problems, and we'll cover some of those. Privacy, let's go back here. Privacy is huge, and it's getting huger, right? I think in the last couple of years, everybody probably knows about a lot of the news events and things that have come out. It's really important for technology companies and platforms to think very hard about privacy. Users, it turns out, care about their data, and they care about keeping their data and knowing where it's going and who's accessing it and why. And so a lot of the changes that we've introduced, especially over the P and the Q releases, are all about clamping down on the ability to get that data when applications don't need it and shouldn't have it, as well as helping users understand when that data is needed, right? So in particular, if you need that data, then you should be asking for that data with the user's permission and their knowledge instead of just grabbing it because the platform happens to make it available. Right? So a lot of the changes, I think especially a lot of the changes that are harder to deal with as developers are specifically because of this, because this matters a lot. Right? I think it matters to all of us because we're all users, but it also matters to all of our customers. And then finally, usability. A lot of the changes that we make in the platform about usability anyway, making Android and devices easier to use in general. But some of those are specifically in the area where they affect your lives as developers. So what are we doing to make devices more usable that end up being changes that you need to account for in your code? So let's go over some of the bigger changes in the areas. The M release. So Marshmallow, we had something in the battery area called Doze. So for years, we had this way of describing performance on the platform saying it's a shared village. Everybody needs to do the right thing so that we can all access the same resources and nobody's burning battery too much. It turns out if you leave it up to everybody else on the planet, the right thing is not going to happen for the user because, of course, every developer knows that the most important application on a user's device is their application, right? I think this is sort of a natural human thing. Well, clearly, if they install my application, they want it to run all the time, and they're OK with me doing all the stuff because they installed my application is awesome. Maybe, right? But there's also things that we could do at the platform level to make sure that applications don't have the ability to really burn the battery down when the user doesn't want them to. So Doze is the idea of noting when A, the phone is not plugged in, B, the screen is off, and C, the phone is not moving. Well, that's a pretty good heuristic for knowing that the user is not doing anything with their phone, so why don't we crank back on the stuff that applications are doing? Make it harder for you to do stuff that clearly the user does not want you doing right now. All you're doing is burning battery. They don't want the results of what you're doing right now. So it defers, it notes this situation, so we can take a little graph here. It's running normally, and then they set the phone down, it's on battery, screen is off, nobody's doing anything there. And then it goes into Doze mode, and it defers things like jobs, and network activity and data syncs, and then wakes up occasionally to do those. So you still have the option of doing them occasionally, but it's in these little sync windows that come up instead of constantly every application sort of on its own doing whatever it wants whenever, right? App standby was another one that was important. It was noting that if applications aren't being used, then we're going to defer their network activity. Because if the user is not using them, then why are you using the bandwidth and the battery to do that thing? In the privacy area, so runtime permissions was kind of huge. And it was huge both in terms of developer impact and the things that you needed to do, but it was also huge in terms of the user knowing what's going on in the system. So previous to that, you asked for permissions in your manifest, and then we advertised that on the Play Store, and then the user says, I don't really understand a lot of this information, but my friend told me I should get this application. Sure. I'll take that thing. It comes down, and then the application has access to all the stuff that they did ask the user about. They follow the rules. Well, the rules weren't specific enough, right? The user had no context. They didn't understand why you needed the internet permission or the phone permission or the delete everything from my device permission. Is there a permission like that? Instead, if you can actually advertise that information in context at the time when you need it, it's a lot easier for them to make the decision about what your application is doing and whether they want it to happen. And also, they can make that decision later, and they can go into settings, and they can check all this information and say, wait. Why is that book reading application using my call log? Right? It doesn't seem like they need this information. They can actually disable that. So not only does it give them more information and more context for the things applications are doing, but it also gives developers the need to then be more prescriptive about the permissions that you are actually using. Do you need that permission? And if you do, maybe you only need it in some situations. And if the user has decided to disable it, what are you going to do about it? Because it is the user's decision to do that. The other thing they're going to do is uninstall your app. So maybe it would be good to actually handle the right thing for the permission instead. So in the end release, we took DOES a little bit further. I think we called it DOES Lite at the time, and now we don't, and I'm not quite sure why. I call it DOES++. It was the idea that actually sometimes they're not using their phone even when it's moving, right? So maybe it's in their pocket while they're driving the car, and we can do a lighter version of DOES, sort of disable some of those things, and then if they then set their phone down, it goes into the deeper DOES mode over time. We cranked back on some of the broadcasts. It was possible to register for these broadcasts in your manifest and say, well, I want to get messages when the following things happen, when the user takes a picture, or they have a video to share, or connectivity changed. And then one of these things would happen very frequently, it turns out, and all of the applications on the device would wake up, and they would all thrash each other in and out of memory because somebody just took a picture. Maybe I want to do something with that picture. Oh, no, this is not something I care about, and then they would go back to sleep. It was too easy for applications to register for this information and for the system to send this information to everybody on the device, and then for the user to suffer, because in the meantime, battery and performance are suffering every time this happens, which is really frequent. So it's no longer possible to receive these broadcasts for picture and video. They basically shouldn't have been there from day one. And if you're getting a connectivity broadcast, you can't register for it at the manifest level. It is still possible to register for it at runtime instead. On the privacy area, we limited the permissions on directories and files. Turns out you could create things, and then at an operating system level, sort of at the shell level, you could get access. Applications get access to things that they really shouldn't have, so we sort of did the obvious thing there. In the Oreo release, so for battery, if your app becomes cached, which is basically one step removed from being removed from the processes, so nobody's using your application, it's in the background, you haven't touched it for a while, the system puts it in the cache state, and then when it needs to free up that memory to use for another application, it'll kill that process. Well, if it's in that cache state, then why is it holding a wake lock, right? And this was a very common thing. Wake locks are really expensive. It's preventing things like maybe the screen going off or CPU going into sleep mode. So we went ahead and removed the wake locks to delete this problem that was apparently hard for developers to fix in a general way on their own. Implicit broadcasts, again, in the same area. Like if we're making it too easy for everybody to register for everything, then the phone, the devices, and the apps are just waking up way, way, way too often. There were application limits put on background apps. This is an ongoing theme in all these releases. Applications running in the background, the user is not doing anything directly with them, and yet they were generating a lot of activity. So one thing is they were creating background services. Well, if you're in the background to begin with, you really need to surface information to the user about things that you're trying to do. Otherwise, you're not allowed to do it, so you can't start that background service. And also, we're not giving you access to location as often as possible. Right? So you could be running this background app and you're getting this location constantly. That turns out to be a really expensive and battery-consuming operation. So instead, we give that you can still access that information, but it is far less frequent. Android ID was changed. There's been a move in the last few releases to make it harder to get these device-specific, non-resettable IDs. Again, it's all about privacy for the user. And information that maybe they don't want to give you. They want to be able to reset their ID. They want to uninstall and reinstall this app or give the phone to somebody else. Whatever it is, there are these situations that require the IDs to be resettable, and some of the APIs didn't really work with that model. So Android ID changes were the first one of those. And then Wi-Fi scanning info. It's possible for applications to scan Wi-Fi and then just as a side effect get information about where the user is. Well, maybe the user doesn't have location settings enabled. Maybe they don't actually want to broadcast their location. So now, if you want to do this information, if you want to use these methods, you require the location permission. P-release, so release before the current preview. Again, battery improvements. App standby got a little more powerful. We have these buckets now, not just is your application being used or not, but basically how frequently. So I compiled this really complicated table here. So the active bucket means actually they're using this thing at the time, so there are no restrictions on any of these things. You can do all the jobs and alarms and Firebase cloud messaging, high priority messages, all you want, access to internet, no other restrictions in there to think of. Working set means it's not active, but it's maybe used daily, right? So this is a frequent application that the user goes into. So since it's not active, we're going to place some limits on jobs and alarms, but the rest of it's fine. Frequent application is not daily, but pretty often. It is something that the user actually depends on. So we're also going to crank back a little bit more on jobs and alarms, as well as we're going to cap the number of high priority Firebase cloud messaging messages that you can receive. Rare means, yep, it's installed. Yes, they do use it. Not really very often, so we also limit the amount of internet access, and then never, user installed it, no one knows why, they're not using it at all. So very strict regulations, very strict constraints posed on all of these. Battery saver improvements. Battery saver, the UI for that, I have always personally hated because it turns off animations immediately and kind of makes everything this discontinuous experience. Animations are turned back on. Turns out that wasn't the real power user in battery saver. But we did a lot of other things. So we may disable location, which again is an expensive operation, just given the hardware and the software involved in getting that information. And background apps, if the user's not using it, you don't get access to the network. The user told us through the battery saver thing, or the battery actually going into battery saver mode automatically, told us that saving battery is the most important thing that you can do right now. So we're going to crank back on the things that actually cost a lot of battery. Wi-Fi scanning throttling. So scanning is very expensive. Think of it, there's one Wi-Fi chip on the system. And if you're using that Wi-Fi chip to, say, watch a YouTube video, and then a background app or foreground app goes in and starts to scan networks and see what's out there, you're going to cause contention through that single pipe, right? And we don't really want to do that. So we placed some throttling limits on Wi-Fi scanning in general. If you're a foreground app, in the latest release at least, you can scan 4 times in 2 minutes if you really need a burst, but otherwise limited. And if you're in the background, only once every 30 minutes. This affects some, I think, corner case apps where like Wi-Fi scanning is what they do. But it was really to move away from the model where background apps could really do whatever they wanted with Wi-Fi information at all times. And it wasn't doing good things for battery. Also wasn't doing good things for privacy. It is possible through Wi-Fi information to access information about location. So now you actually need the permission, and the user needs to enable location settings, because they already told us that they didn't want anybody to get their location, so why are we giving them that information through Wi-Fi scanning? Also in privacy, limited access to some of the background sensors. So if you're running as a background app, you can't get access to the mic and the camera, which just seems to make sense. Like foreground app, great, but why are you actually accessing it if you're running in the backgrounds? New call log permission. We had a general phone permission, but that didn't make it obvious to the user that applications were actually getting access to the logs that they'd made. To the calls that they made on the phone. So there's a new permission that we require for that. And cell info, again, it was sort of a backdoor way of getting location information. So now you need location services enabled to get access to some of those methods. In the usability space, this is kind of an important one in the last couple of releases. We are now changing the way private APIs work. So traditionally, we have this public API service, and we hope really deeply that everybody uses our public APIs because they're so awesome, right? But sometimes people will say, you know, that method isn't quite what I wanted, and they'll go and look through the source code, which is great. That's why Android source code is out there. And they'll figure out, oh, there's this other method they use internally for doing this. I'm going to call that one instead. And then the next release, we change the parameters in that method, or remove it, or move it to a different package, or do whatever we want to do because it's private. It is called private API for a reason, right? It is for us to use in implementing the platform. It's not for developers to use externally. And the reason that contract exists is because when we change it, your application will break. So we assumed that that was kind of enough disincentive for people to avoid them anyway, but it wasn't. They would use these private methods, and they would release their applications, and then users would buy a phone with a later release, and that application would crash. Or even worse, they upgrade the same phone to a later release, and the application crashes because we made a change internally that we didn't think you were depending upon. So now we're taking a look at all of the private APIs that are being used, methods being called, fields being accessed, whatever they are, and we're either determining, you know what, nobody should be calling this method anyway. There's a really good reason why it's private. This functionality shouldn't exist, and we'll just deny access to that thing. Or we're saying, actually, that's a valid use case that does not exist in the public API. So we're going to create a public API for it, point developers at that, and then in future releases, deny access to this private API. Or in a lot of cases, there's not really a good reason for them to be using reflection and accessing the private API to begin with. So we deny access and say, actually call this other method instead. In some cases, people just use fields. I don't know why. Maybe they're assembly programmers that are new to this whole Java thing. But they're calling, like, we have setters and getters. Why are you not using those instead? So again, don't use the fields. Point people at the methods instead, and deny access to the private APIs. All right, now we're up to Q, battery, Wi-Fi enabling. So the user says, I don't want Wi-Fi enabled, and then an application says, oh, but I do. So we're going to go ahead and do that thing. That is no longer allowed. Instead, we introduced a new API called settings panel. And you can write code like this, where you ask for one of the following actions. There's basically a subset of things that you can do in settings that you can now access directly from your application. Say, OK, I want you to bring up a panel that gives information to the user about Wi-Fi. And then it pops up a panel that looks something like this. And then the user can choose to enable Wi-Fi. So that's great. If your application needs Wi-Fi, we understand that is a real use case. But you are not allowed to enable it on your own. Instead, involve the user in that decision. You can explain to them why you need it, and then pop them into the settings panel, and hopefully they do the right thing for you. Let's see, privacy, scope storage. This is a huge one. So who had to deal with scope storage changes in the Q preview release? Oh, that's good. All right, so I think Mark Murphy is giving a talk here. I know he has opinions on this. One of the interesting things in this was we made some very draconian changes with scope storage in Q, and then we got really strong feedback from some developers that that was too much. That's very difficult for them to handle, and we made major changes in what we were trying to do to make it easier for developers to migrate to the changes. It's really important stuff. Again, it's because the user doesn't want to share information in the same way that some applications were using it. Right? So scope storage is the idea that applications, you can read and write all the files on external storage that you want for your application. No permissions required, that's fine. But if you want access to somebody else's files, files that were created by another application, then you need these permissions. So the read and write external storage permission, as well as using media store. And in addition to that, you can only access photos and video and audio files. If it's something else random, if it's a PDF file, then you should be using the storage access framework, which basically pops up, hi, you're telling me 5 minutes? You're telling me 2. Okay, I'm going to skip really quickly through the end of this. You know, I was watching the timer. The timer says 12. I want that to be on the record. All right. So scope storage, get used to it. It's important for users. Location is permitted through photos, but it's very limited. Again, do you need this information? And the user needs to know about it. And another background location thing. It's important. OK, I'm going to skip through these because he told me to. All right, usability, background activity starts. You cannot start you cannot start an activity if you're already running in the backgrounds. And more changes to the private APIs. So if we look at these, basically battery changes are about limiting the number of things going on in the system to preserve battery. Privacy is about giving users more control and information and letting them make these decisions instead of leaving it up to the applications. And finally, we want to make the device behavior more predictable for users. I'm going to take that 2 minutes, and I'm going to do a really quick survey. All right, so we have lots of information about learning for users, and I think it's a little confusing to find. So I wanted to walk through really quickly what we have. YouTube videos, Android developers channel. We have dev bites and conference talks and release overviews. Who uses them right now? All right, so maybe about half the room. Great. And listening, we have, it says plural, but there's actually only one. Android Developers Backstage is a podcast that I co-host with a couple of friends. Who listens to ADB? Maybe about a quarter of the room. All right. Coding. So we have courses on Udacity, these full courses on learning things like Kotlin and programming Android with Kotlin and other things, not even necessarily about Kotlin. Who uses Udacity courses? All right, maybe about 20%, I'll say 20%. Code labs. So deep dives into specific topics here. Who uses the code labs that we have? All right, maybe 30%. And coding samples, 3 different sites. Sorry, this is so confusing. We're trying to fix that. Small examples on doing things. Actually, the best way to get to the samples is through Android Studio. Who uses our samples? All right, maybe about a quarter, 20%. And the Android developer site, I hope everybody in the room goes there. Reference documentation, release notes, tutorials, and overviews. Android developers blog, random information, tends to be a bit scattershot between play, marketing, distribution stuff, and some deep dive technical articles and releases. Who goes to the Android developers blog? Maybe about 20%, 15%. And Medium, Android developers channel on Medium, technical articles by Android engineers. Who goes to Medium to read that stuff? All right, maybe about 25, 30%. And then I am ending very quickly. Tracking the latest stuff, I think it's confusing to figure out what Android is doing because we have all these channels going out, all the learning stuff, but also we just released something. Hey, there's a new Android X library out there. So I started writing something new a few weeks ago called Now in Android. It's on Medium. Please check it out. Actually, who's seen this so far? I'm going to say 5 people. OK. So it's basically supposed to be a filter on all the stuff that we're doing to make it a little bit easier to find that stuff. And apparently, I'm out of time, and thank you.